Thank you, Peter, for this excellent introduction. I just put on my T-shirt and jacket to pretend to be a data scientist here. So where should we start? You may think about AI. We heard about it. How do you change an organization, such as Volvo Group, to use AI, to use innovation with data? And I put a lot of buzzwords in the title so that all of you come in here to listen. And now I have to live up to that. And actually, I would like to say our challenge at the Volvo Group with this is not really the machine learning or the data science, putting the algorithms together. That is just a few lines of Python code, typically. That's not the challenge. And you may think, OK, it's the 80% that Teradata showed you, the data wrangling. How do you prepare your data? Well, honestly, that is a problem. We spend probably 90% of the projects on that. But that's not the big issue. I would like to say that the really big thing for us is communication. How can we efficiently communicate the things we're doing? And as an example, imagine that I work on a gearbox problem in one of our trucks, and I walk up to this engineer, the expert in gear shifting and everything, with 30 years experience, and I tell him, well, I looked at this problem, and I can say with 97.2% security that the problem is due to tires, due to ambient temperature, and due to the fleet size of the operators. That's the problem reason. And for me, that is like a clear understanding from our field data. I gathered all the data, processed it, I did my analysis with machine learning and everything, and I got this result. And I try this, and I can tell you, in a good scenario, I would get a couple of new questions to go back home and redo my work, because I didn't care for all the things I had to care for. And in a bad scenario, I'm just thrown that, and people ignore me and say, OK, that's good, but I need to do my lab tests now. I need to focus on my work. So how do we do that? How do we communicate our findings and the data science work and the power of the data? To be honest, already the ancient Greeks, they knew how to convince a gearbox engineer at Volvo. They said there were three things you need to do. You need to have logos, you need to have ethos, and you need to have pathos. Have you heard of them before? So you can see it's a triangle. Logos, you have to be correct and logical in the things you're arguing for. Ethos, it's about your trust and your person. Can I trust you? Can I rely on what you are saying? And pathos, we address the feelings, be passionate about what we're doing. And as an example, as a data scientist, you focus a lot of your attention on logos, preparing the data, doing the algorithm, selecting the completely correct model, etc., presenting the statistics. But how can they trust you? Because they can't understand every single step of your work, right? So they need to trust that you did actually take the right data set and you put it in the appropriate model. And that is all about ethos, trust. And then pathos is about packaging your findings in such a way that it's nice to look at it. Otherwise, people will ignore it. And typically, we do slides, I'm one of them, where you need to spend a lot of time just drilling out what is actually on this slide. What do I need to look at? Did the army march to the west or to the east, etc.? So these three we need to keep in mind, logos. And on the opposite curve, I would like to stress, you saw some examples before. I'm not saying they were not correct, but management consultancies or trendsetters, they focus all their attention on ethos and pathos. They are trustworthy, they were properly dressed, and they have statements that are really bold, like our experts, they analyzed this and said, all over the country, if you're not doing AI already, you are lost. And we address your feelings on that. So they didn't really add any logos, but we trust them anyway, and we get frightened. Because we don't have the logos either. We can't falsify them, typically. So that's a little bit what I will talk about today, how we communicate AI, how we communicate visualization, and the analysis we do. And my name is Fredrik Moeschlin. I'm from Volvo Connected Solutions. I have a background as data scientist, as physics engineer in the background, But we're working a lot with management consultancy and the questions you need to address to communicate findings and change an operational model, for instance, with data. And of course, I need to show you some stuff about Volvo. Volvo Group, we are doing a lot of different transport solutions. My favorite is bikes, which we're not doing. But not so many cars, that's Volvo Cars. And we have 100,000 almost employees. And most of them are not data scientists. But we need to communicate with them to enable their work and their possibilities. And with connected solutions, we focus on connectivity, one of the largest trends right now, connectivity. But we have electromobility, which is coming massively now, and of course, automation. And the combination of this requires good connectivity. So at the Volvo Group, we have at least 800,000, approaching 1 million connected assets right now, delivering continuous data. And this data has an enormous power. If we can unleash this power, enable the value of it, utilize the modern techniques of AI and other things, then we have the chance to actually change an organization and continue changing it all over the time. And that's what I'd like to share with you. Unfortunately, we have GDPR. So I moved to Planet GPX, an open source. I don't know if you know Planet OpenStreetMap, hands up. And Planet GPX is sources with tracks that people upload to feed OpenStreetMap. And you can download that, and part of it is public, and you can work with it. So really contributions to OpenStreetMap for enabling this. And if you look at the map, you get an idea where they have their points. And of course, we can have a look at it and see if they were moving, if they were traveling, what would it look like? And this is Europe. You can imagine just getting an understanding of what data do we actually have, how do they move these vehicles, and this raises an understanding among people at the Volvo Group. Okay, we have that much data, but then you could look at the fill rate, how many trucks are traveling empty, or you can look at other things here. So it gains an interest, and it also gives it an overview, and with map data, we talk a lot about projections, and I prefer not to project the data, so this is actually just a globus showing you some of the points around the world. Now I'm getting a bit dizzy. And my favorite finding here is that most of the world, of the Earth, is actually blue. But we don't see it on these maps because they focus on what is not blue. So what is also nice is that, of course, we can do these kind of bar charts here as well and look at where is the density, where do we have a lot of vehicles. We can make selections on these and say, okay, this is where we have our trucks, our buses, etc., etc. And I'm not very fond of bars. You could do triangles if you prefer. Or actually, more logically, you should probably use hexagons on this. But this is just playing with the data. And by the way, this is a prototype that I built in processing. If you're aware of it, you should have a look at processing.org. And it's just about showing you the possibilities, and also this is something we do internally a lot to show the possibilities with data among all our employees. So, what can we do with the data? This is nice, but doesn't add very much value, right? So, what if we have an issue, like the gearbox or something else? Then, of course, we could go back here and look at the data points and say, okay, why do some of them have problems and others not? And this is, of course, interesting to pinpoint what is driving this. Is there a root cause? Is there something we can actually do with the software update? So do we need to recall a lot of vehicles? That can be really expensive. And looking at it like this could possibly render some understandings. Do you see any patterns? Maybe it's Germany here. We could use the geospatial data on this, do some mappings. But this is now hypothesis-driven. And to be honest, is there any difference compared to this one? This is just a random walk. Dots moving around like crazy, randomly. But you will see patterns in this as well. And actually, the truth is, looking at random walk for a long time, if there are no patterns revealing, that is highly unlikely. And we could work with that for a long time, but that's not really adding the value. So we need to move from hypothesis-driven work, assessing hypotheses, towards statistics and machine learning. And just as an example now, these are some features or some attributes that we could get from the connected data. And of course, we could start looking at them and say, okay, is there any relationship here between the driven axis, the road condition, and the acceleration of the vehicle? Maybe that is driving the problem. Or is it something with seasonality and braking, or the country or the traffic? Actually, these are just a few parameters. When we work with this data, we generate a lot of features that can better describe the data in certain ways. And we ask our domain experts to help us engineer more features so that it looks like this. And now the work is a bit harder to do manually. And fortunately, my computer is really good at doing this. And that's what we call machine learning, trying out different combinations, looking at, is there any predictive power in these two together? And there's sort of a way to try to visualize methods like random forest or boosted gradient descents or even deep learning in a sense. So the value of this is that we get a highlighting of features. Some of these features are very important in describing the issue, while others are not. Now I'm just randomly picking some features, but we don't want to go to our stakeholders and say, okay, we found the perfect black box model here explaining your issue. And then they say, okay, good, what should I do with that? But I can pinpoint the two main features driving this. And now I can go back to my ugly points and say, please arrange according to these main features. And now you see that, okay, there is actually something covered in these two features. Something is revealing here, which requires actually both to be obvious, the blue and the orange ones. And I have something here. But I'm far from finished. I have the possibility to show what I actually did with the data in the different steps so that I gain trust and I get an understanding. And if I try to do it a little bit nicely, they will be engaged and passionate about it as well. So they will actually ask me a lot of questions along the way and say, okay, Fredrik, how can you help me with this? And now my task is to put myself in their position and say, okay, what does this mean to you? What do you need to do to reveal the underlying dynamics behind this? And that is the challenge, and that requires a lot of communication. So this is something we as data scientists look at as, okay, this is a clear finding. We are probably having a F1 score of 98 or something, 0.98. Great. But there's quite some left. But I'll stop here in this particular case, which is faked with the GPX data from OpenStreetMap. And I'd like to go back here to this slide and really try to say, this is my message that I want to share with you from our experience and my experience. It's really about building that trust in your work, which requires a lot of work. Showing your data lineage and being able to say, I'm actually able to stand here and say that I'm fairly convinced that this is what is going on. And you shouldn't do it alone. You should work with your colleagues and ask them and get their input, of course. But in this picture, would you like to have a bus traveling in your cafes? Probably not. But how can we gain trust in this bus? This is actually a bus now traveling at Lindholmen in Gothenburg and into town. And we are slowly getting trust in it. I'm driving with my bike every day past it, and I know that it has a geofence, so in that area it cannot go faster than 15 or 10 kilometers an hour. I know there is no noise coming out. So even if it's massive, it's slow, it's quiet because it's electric. And I'm gaining trust in it. And that trust is being built, the ethos part. And there's one way to really improve what we're doing. Build that trust. The second thing is put yourself really in your recipient's shoes. Work one day with that a gearbox engineer and sit down and say, okay, how are you actually working? What do you do in Excel day to day? What would you need from us to be a little bit better? What would you need to learn? Is it a tool that you need, or is it the data you need somehow? That helps a lot. And try to put that extra touch on what you're doing. Ask your friend, do you really understand what I'm doing in this slide that I'm presenting? Does it make sense? Am I missing some very important fact? And then, of course, add that passion and try to do things that you're really passionate about. And for me, I'm really passionate about doing these kind of presentations and doing these kind of visualizations, and I think that's great fun. So I hope I kind of give you that message. And this, what I built here, is something I built together with my colleagues, and we build a lot of such prototypes to try to convey the message and help enabling the organization to realize what do we have, what data do we have, what information do we have, what value could we make out of it, how do we need to start working with it, and then it comes the data wrangling, the AI, etc. But on prototypes, it's very good to build it quickly, communicate the message, and see what input you get, what more questions do you get. And I also like to share processing, which is where I built this demo. Excellent tool to start. You need some basic coding skills, but you learn along the way, and it's great fun, and it's a really powerful tool. It hasn't got enough attention, I think. And OpenStreetMap, excellent data provided in different ways to work with. And that's what I wanted to share with you today. Thank you very much.
Thank you.